We commonly think about serverless as something that helps us not have to worry about infrastructure. But what if serverless was also a way to reduce the amount of application code that we need to write? What if we could replace application code that we would need to write and maintain? What if we can replace that with automation code and use the same language to do that? And along the way, we make our applications more robust and more scalable. Well, that's what we're going to talk about today, because that is refactoring to serverless.
And just to make sure you're on the right session, today we are not talking about application modernization and the 6 hours of cloud migration like replatforming. Today, we'll talk about how you can take your existing serverless applications and make them even more serverless native.
And as you would have guessed, this is Sindhu. She's a senior solution architect helping our strategic customers in the education tech vertical.
And this is Gregor. He's a senior principal evangelist and working with our serverless team.
So let's talk about automation. When we think about automation, usually we have a picture like this in mind, right? Like an assembly line that helps us avoid manual steps and helps us avoid toil. And that's great, right? Because on an assembly line, you can build things much faster than you could do by hand. But this is also 100 years ago. So in cloud, automation actually plays a much bigger role than just avoiding toil.
Cloud automation is much more than reducing manual steps and toil. In fact, that is reflected in the language that we use to describe our automation. We started off with object-oriented language with syntaxes like YAML and JSON to describe our infrastructure. But we see now more people adopt our familiar programming languages using tooling like AWS CDK, which is short for Cloud Development Kit. So who here has used AWS CDK? A show of hands?
Yeah, not bad.
I see quite a few hands. So if you haven't used AWS CDK, it is a framework that allows you to write your infrastructure as actual code using familiar languages like TypeScript or Python. Because it is object-oriented, it allows you to write higher-level abstractions like VPC or a cluster within that VPC. Now, a web-based application is a common use case, and so we have in the AWS CDK a construct for that. So your network load balance Fargate service will help you provision the load balance service, and just with one construct. It's as simple as that. And because of using this higher level construct, your CDK code is much more compact and readable. So this would have translated into over 400 lines of code if you would have written in CloudFormation. Now, because it's also using object-oriented language, you have editor support with inline documentation and autocomplete. We used TypeScript in this example, but CDK also supports 5 other programming languages.
So as we've seen, automation plays a much bigger role in the cloud, and you could even go as far as saying, without automation, the cloud would look a lot more like just another data center. And we have very nice data centers, but usually customers don't ask us to build another data center for them. So cloud has become really an essential part, or automation has become a really essential part about what we're doing in the cloud. Now, as an architect, I always like to break things down and understand better the nuances. So let's do this for automation as well. Because automation in the cloud does actually quite a few things. We commonly think about it as provisioning resources, right? And that's great, but by themselves, the resources don't really do much, right? I use a very simple example here of some EC2 instances, load balancer, API gateway, right? You need to deploy code onto these instances, but then you still have just disconnected pieces. You also need to compose. You need to configure what talks to what so that these resources actually make a working application. And then last but not least, you surely have some configuration settings. You might have a primary and a secondary database. You might change logging levels, right? There's configuration on top as well. So when we talk about cloud automation, it's no longer just provisioning, but it really spans across all those 4 different aspects.
And today we are talking about serverless application. So that changes a picture a little bit. Infrastructure provisioning is already done for you, and deployment is as easy as placing your zip file in a bucket. So when we talk about serverless, the 2 aspects that come more important is composition and configuration. Composition connects loosely coupled components into a single working application. It's also very closely related to granularity, whether you wrote 2 Lambda functions or a bunch of functions. The more functions you have, the more important the dependencies between them become. And these components are connected by services like Amazon SQS, SNS, or EventBridge, which then you have to configure so that you can either route the message, transform, or filter out messages.
So both elements that Sindhu mentioned here, they really have nothing to do with infrastructure, right? This is application and topology. So we could even think about it that our slogan, infrastructure as code, in a serverless environment, which by definition doesn't concern itself with infrastructure because we do that, that we really, when we use automation, it is really application architecture as code. What's the granularity? What talks to what? Is that synchronous, asynchronous? Those are aspects of your application architecture that you can now program. And you can program them in object-oriented languages with CDK. So now we could say this is really application architecture as actual code. And that leads to some interesting insights. So let's recap very quickly. You have application code and automation code side by side. You can use the same language to do either one. So the question should be, can you do similar things on both sides? And the answer is yes. And the answer is actually you can replace application code with automation code. And that brings us to what refactoring to serverless is all about. Now, refactoring is not a new term. We borrowed that from Martin Fowler. He wrote a book about this about quarter century, like almost 25 years ago. And that is about improving the structure and the design of your application without changing the functionality. So refactoring is not about feature releases, it's about making the structure of your code better. And people use this frequently in the context of test-driven development, like people call this the red-green refactor development, right? You write a test with a specification of what your application should do. You haven't implemented that yet, so the test will be red. Then you implement the function, it goes green, and then you look at your code and you improve your code as a refactoring, and you do this in a continuous cycle. So a lot of development tools support this. Coming back to our world, right, the serverless cloud world, we also feel that we can improve the structure of our application without changing the functionality, and we do that mainly by replacing application code with automation code, specifically CDK code. How that works, we best show with a simple example.
Yeah, we talked about refactoring to serverless, so let's look at an example. On your left, you have a simple Lambda function. It's executing some code, and at the end, it's sending the result to an SQS queue. So what's wrong with this code? It's a trick question. There's nothing wrong. This works absolutely fine. Then why would you want to refactor this? Well, if you see, the Lambda function is mixing your business logic with your application topology and integration. Which event is sent where is buried in that code. Say in future, you want to change from SQS to an SNS. You'll have to find the application code, make that change. Thanks to serverless, we can do better. So let's look at how we can refactor this example. On the top is now the refactored application code. It's using Lambda destination. Lambda destination is a feature by which Lambda runtime can send the function's result to another AWS service like SQS, SNS, EventBridge, or even another Lambda function. And all of this without writing application code. So your function it has a...
Sorry, I'm not clicking. Can we stop moving slides? Okay, thank you. Let's go back. Sorry.
Let's go back.
I'm not touching. Go ahead, sorry, go ahead.
Okay, where were we? So now look at this example on you're looking at Lambda destinations. As we said, Lambda destinations can now send a message without you actually writing the code. So your function on the top has become small. Less code, which means less maintenance. And where is that topology? The topology is in your automation code at the bottom. What this means is, let's go back to that same scenario. If you're changing your SQS to SNS, that change will come in the automation code and not the application. So this gives you the benefit of having a clear separation of concern between your business logic and application topology. And here, if you see, we are using actual references of the services and not passing in environment variables like QURL. So that was a simple example. Let's move on. Take a little bit complex example. What I want to show you is refactoring not only occurs at the code level, it can also occur at your architecture within your workflows or orchestrator. So to see that, let's see this example. I have a ride booking app. There are 3 Lambda functions in orange that handle a customer's booking. Your booking service, the payment service, and the driver assignment service. And the coordination between these services is choreographed using events through EventBridge. This is an event-driven architecture. It is scalable and flexible. But you'll notice that the Lambda function plays a very important role in this architecture. It needs to pass events as a response so that the next step in your workflow is triggered. Also, our business flow is distributed across these 3 services. So to manage the transactional scope becomes difficult. Say a service goes down, no events get passed. So we can do better. To address this challenge, now let's look at the refactored design. In this refactored design, we replaced the choreography with a step function that acts as an orchestrator. The step function is now going to invoke all the 3 Lambdas in a specific order. So now your Lambdas are playing a passive role in this architecture, and you have a complete visibility of your workflow. You can track the status of each workflow instance. Now with architectures, there's always trade-off. So let's talk about that. Your architecture is now a little tightly coupled with a single point of maintenance. Now this could be good if you want control. However, this could become a bottleneck if your business is constantly evolving and you need to add or remove services. So that, to summarize, was how to look at refactoring. Let's look at another example, Gregor.
Yeah, so Sindhu showed 2 examples, right? We didn't change any functionality, but we changed the structure of the application. So I have one more example, and that has to do with one of our favorite words when we talk about distributed systems, and that's the word coupling. Because refactoring to serverless can also help us reduce coupling. So this is based on a real example that I actually took out of some workshop code, and again, it sort of starts very simple. It's a Lambda function, and that function does some business logic, but then it writes the results to a DynamoDB database, and then it also publishes an event. And again, you will think, okay, that is, ooh, we have the clicker thing again. Do I go back to? Yeah, this was for the people who didn't pay attention. You get the previous slides. Yeah, see, like, look now, choreography, orchestration. Okay, good.
We'll have a quiz at the end.
Yeah, it's Monday, folks, so we can make it. All right, here we were. So there we go, DynamoDB and sending, oh, please, come on. I promise I don't do anything.
I should take away the clicker from you, Greg.
Yeah, maybe you click, I don't know, maybe it's me, So anyway, the Lambda function does two things. The slide will come, right? It updates the DynamoDB table and it sends an event. And same consideration, right? This is code that people write, but it has some issues. For one is, again, you have the topology mixed in your code. The database you could consider something local to the function, so obviously write to the DynamoDB table. But sending the event that has something to do with other functions and communicating and mixing the two is maybe not a good idea, because what if the event needs to go somewhere else? Like, you need to modify your application code. But the more serious issue is probably that you have no transactional integrity across the two things. What if you write to the database and then you send the event, but for whatever reason the event sending fails? Could be a runtime problem, could be also a coding problem, right? Then you have your system out of whack. So then you need to retry or undo the database update, right? Immediately you're starting a lot more code than you should actually have to. And as we said before, good job, like we're back on track here.
Finally there.
As we said before, there is a better way to do this.
Okay.
There's also a better way to handle the clicker. So the better way to do this is DynamoDB has a feature called DynamoDB Streams. And that can actually publish an event every time you insert or update something into the table. Now, what you can do is you can read that stream from EventBridge pipes and publish the event that way. So what happens is that now all the application does is update the table, and it has no knowledge from what happens afterwards. So these two aspects are completely decoupled, and that's very nice. The application knows about the database, that's part of the Lambda function, and all the event story, that is done in the background, and it has retries and queues and all the other things to make sure that that stays fully consistent. Out of curiosity, who has actually used EventBridge pipes? Okay, more hands than we launched last year. So last year, we only had a few hands, understandably. It's actually a very nice tool to make these kind of connections, right? To decouple your application from having to send these kind of events. And here we have the code. I'll be very careful. So here we have the code, right? What we had on the left-hand side, have some business logic, write it in the table, and then send the event. Looks harmless enough, but as we explained, right, this has issues because you need to build your whole transactional logic around it. On the right-hand side, life is much better because all that code is essentially gone from the Lambda function, and the runtime deals with that, right? Yeah, thank you. The runtime deals with that as it should, right? This topology, this event stuff, the resending of events, time to live, latency, all these kind of things, right? That is really the runtime's job, not your application's code job. So having that separation is a real advantage, and that's the essence of many of these refactorings.
Looks like we have to go to our manual step of clicking.
Oh, manual clicking? Okay,
yes.
It's your turn, I will click.
Interference from other rooms.
Okay, yeah, no worries. It's like technology, sometimes it gives us some trouble. Go ahead.
So we saw 3 examples today that showed how you can improve the design of your serverless application by writing less application code and more automation code. The automation code better utilizes serverless capabilities and brings a clear separation of concern. So we started building a catalog of these refactorings. And when we did that, we started seeing at the reasons for why you would want to refactor. So let's talk through these reasons now. The first one we already talked about of better utilizing your serverless platform capabilities by using Lambda destination or event bridge pipes. You get the benefit of the scale and robustness of AWS. Secondly, again, we're going top to bottom if you're trying to figure out where I am. The second one, AWS is constantly evolving and adding features. So by incorporating these features, something that you would have built on your own, but by refactoring to use serverless out-of-the-box features, you can also help reduce your maintenance code. Because you don't have to now worry about your runtime of your Lambda getting deprecated or having to patch things. Now the inverse could also be true. That is, your application needs have evolved and it cannot be satisfied with the service capabilities. Now in which case, you will remove it from your automation and implement it as part of your application code. Now we talked about how it can improve runtime characteristics like latency or availability or transactional integrity. Another important runtime characteristic is cost, something that we see our customers talk all the time. So if you can remove a Lambda, replace that with an existing service integration, you can save the cost of that Lambda invocation. Now, this is what we mean by refactoring to serverless. Serverless is the highest form of leveraging the platform capabilities. And refactoring to that goal means using the platform for all it can do. So the patterns that we talked about can be categorized into these dimensions.
And you see the examples here we had, right?
Yeah. So we covered the first one, I covered with the Lambda destination example, and Gregor talked about the last one, which is the DynamoDB stream. Another example would be if you have filtering logic in your consumer applications, you can remove that and put it in an event bridge. That was about leveraging platform capabilities. The next one is AWS evolving. Just to throw a stats, last year AWS released 3,300 service features. So that means you have a lot more opportunities to take benefit from that.
Yeah, and we had reInvent, so I'm sure more good things will come, right?
Yeah, and it started coming in too. So let me talk about the first one. So this is an example in your service integration space. Step functions can now directly integrate with over 200 services. So you can directly connect from step functions to any AWS services using the AWS SDK integration. What that means is, say you have a recognition task. From step functions, you can directly call the recognition API, eliminating the need of a Lambda function. Likewise, from step functions, you can directly read DynamoDB tables, again, eliminating Lambda functions. This means there is less moving parts, less code to maintain, lowering your cost. Talking about the reverse, your application needs have evolved. And say, for example, you have a very sophisticated pattern matching that cannot be done through event bridge rules. We have seen customers do that too. They take that logic out and build it in a Lambda function. And if you're looking to improve your runtime characteristics, we have quite a few refactorings for you. Let's look at the bottom too. So I covered this use case earlier with the ride booking app, where we replaced the choreography with a step function orchestrator. Now, because of the trade-offs, remember, that was involved, we also see that you can go in the opposite direction. So we have customers who replace their orchestrator with a choreography, and that is also valid depending on what you want to achieve at the end for your use case. So that was our catalog of refactoring.
So yeah, so where we are is we said, yeah, application code, automation code, achieve the same thing, use the same language. You can shift from one to the other, most of the time from application to automation, but in some cases the other way around if you need to. And the orchestration choreography examples were very nice because we're not here to lecture sort of there's one right way. Sometimes both directions are viable, and it's good to give names to these things and to understand the trade-offs, so it becomes much easier to talk about these kind of refactorings. Now, we need to confess one little thing. When we borrowed the word refactoring, what we're doing here is slightly different than the original Martin Fowler version, right? We're not introducing a variable or extracting a method in your source code, right? These are distributed systems. So if you take a lambda function out, you get some nice properties, but if you add another component, that might have an impact on latency, runtime, perhaps even cost. So now we want to talk a little bit about how true are these refactorings really, and do they have an impact on the operational aspects?
So let's look at the example that I talked about with Lambda destination. Now, did that preserve the behavior? Well, it turns out there were a few nuances. The first, Lambdas can be invoked synchronously or asynchronously. But Lambda destinations will only triggered if your function is called asynchronously. Now, in an event-driven architecture, usually this doesn't matter. But if you have a specific use case where your functions are called synchronously, say you have a real-time request response model, the refactoring won't work. The next one was with the message payload. So look at your screen. On your left is the message that was sent when you directly wrote the code, and on your right is the message from Lambda destination. The Lambda destination wraps an event envelope which adds additional metadata along with the message. What does this mean? This means that at your consumers, you will now have to parse the payload and extract the necessary information. The next one is about when the Lambda destination gets triggered. Lambda destination gets triggered at the end of your function invocation. Now, if you have a specific use case where you need to send the message at a certain point, well, this won't work. Maybe at that time you should probably think about splitting the function.
Yeah, to be honest, in an asynchronous environment, the first argument would be if that matters, right? There might be something else wrong with the architecture. The only case we could really think about is if you have a very expensive operation, something that takes a lot of time, and you want to send the message before you do that processing, and I think then the right answer would be, why don't you split that into two functions?
So what we want to take out of this is, yes, there could be some nuances, but always look at the bigger picture. By doing the refactoring, you gained a higher resilience and transactional integrity.
So let's come back to the distributed system aspects, right? So we're talking about the nuances here. So I wrote a whole blog post about this, so I have a little summary that we have a link at the bottom there. When we talk about distributed systems, right, the serverless cloud systems, they're inherently distributed, right? That's what gives them all the nice properties, right? They have scalability, auto-scaling, graceful degradation. They can all do these amazing things because they're independently running parts. But one question, of course, is latency, right? If I poll from my DynamoDB stream and then have event bridge pipes publish this event, does that actually increase my latency? And in this case, it actually does, because event bridge pipes polls from the DynamoDB stream. Now you can configure this, you have timeouts, you have batch sizes, but ultimately there's another running part, so it takes slightly longer to publish that event to its destination. Now I've done some very non-scientific experiments, right, like little demo apps to try this out, and it was about sort of 100 milliseconds that this took. At the same time, keep in mind the Lambda function got shorter, right? So the Lambda function no longer publishes that event. And when I tried that, there was actually also 40 milliseconds. So always look at the big picture. Yes, latency might be something that impacts you, but the time you spend here, you might save over there. And actually, these kind of architectures are often more optimized for high throughput than for low latencies, right? Because these are asynchronous architectures. So that is around the latency. The other one, of course, that everybody wants to talk about is cost, right? And that is actually the title of my blog post is, I didn't want to put it on the slides here, is I made everything loosely coupled. Will my cloud bill go up, right? So will this cost you money? And the good answer is probably actually not. And again, disclaimer here, right? These are a little bit sort of lab kind of experiments that I ran. So please use the tools that you have, like anomaly detector, cost estimator, right? This depends on event sizes, regions that you run in, right? So that as a short disclaimer. But here is what I found, right? So let's come back to what we did. We had a Lambda function, updates DynamoDB and sends an event explicitly, and we changed that into just writing to DynamoDB, using a stream, and then using pipes to read from the stream. Couple of comments. First thing is very nice. Once you use pipes, you don't pay for the polling from the stream. That is built into the pipes price. Pipes will cost you, depending on the region, so this is like US region, I think I picked your US East, right? Will cost you 40 cents per million. But the Lambda runtime also went down, and I just picked some numbers, I don't want to say random numbers, some like sort of typical numbers. Let's say that's like a 256 megabyte Lambda. So the 40, 50 milliseconds that were saved by not having to write the event actually saves you 20 cents. So it's like, oh, I'm getting half of my money back. Not bad, actually. Two more important considerations here, because one is look at the big picture. Because before I was sending an event to EventBridge, right, when we showed the original code. Well, now I have already, or an EventBridge bus, I should say properly. Now we already have EventBridge pipes. EventBridge pipes can also transform and route. So do I still even need to send this event through EventBridge, or can I now send this event to its proper destination? And then the whole thing flips very much in the other direction, because EventBridge is about $1 per million events, right? And I'm actually in the black very much. So don't look at this thing, oh, I can't put an element in because it's going to cost me 40 cents. No, you might actually end up with something that's less expensive once you look at the whole end-to-end chain, on top of all the benefits that we already talked about, right? You have the whole topology managed separately from the application logic. The other thing not to forget is serverless is cheap, right? Think about what one developer hour would cost you, and how many events you can send for one developer hour. So unless you're running Black Friday, right, you're probably doing pretty well refactoring things so that they're easier to debug, easier to understand, makes your developers more productive, because that developer hour is probably worth like 500 million events alone. So never forget, right, the runtime cost is not your total cost. Developer productivity and maybe avoiding a bug or avoiding a mistake is worth much, much more money than the 20 cents or the 40 cents per million events we're talking here. And we haven't even mentioned the free tier that helps you on top of that. So that around latency and cost, yes, you know, be smart, look at what it does, but it's not automatically slower or more expensive. Quite often, it can actually do the opposite for you and save you money to architect things this way. Last comment, one consideration that's also coupled to operational aspects is switching costs, right, when we talk about costs. Do I get locked in, right? Will this make it harder to run this somewhere else if I needed to? Really good question, and mini advertising. On Thursday, I have a whole talk on this topic. ARC 307 is called Do Modern Cloud Applications Lock Me In? I'm always a little bit proud to be able to speak and reinvent and use the word lock-in, because, you know, vendors, we don't like to say this so much. So we have a whole talk there that talks about switching costs and dependencies and how to manage that aspect. For now, let's dive into a little different topic, and that is we kind of find ourselves in a slightly different universe now, right? This application and automation code, this all becomes the same, and we shift from the left to the right, right? So that is a very interesting space, And actually, there's a lot more going on in this space. So I want to share one slide here that shares a little bit my thoughts where we are. So when we look at cloud automation now, we can split that into 3 separate dimensions. The first one is the kind of language, right? That's where Sindhu started in the beginning, right? We have a lot of document-oriented languages, right? That's a JSON, YAML kind of things. Then we have object-oriented languages. That's where most of the CDK languages play. And there's also a lot of movement in the functional languages. For A, you could use CDK with F# if you wanted to, but there's also things, we have like QLang is quite interesting. JSONet can do some of these things. So we have different choices of language. One little soapbox I always have in this place is we tend to conflate the word declarative. So declarative automation means that your automation describes what your infrastructure or all your resources should look like, and the system figures out the current state, the difference between the current state and the desired state, and basically gets the delta so that the current state becomes the desired state. That's what we mean by declarative automation. That has nothing to do with declarative languages, right? CDK is object-oriented, like people say, oh, that's like an imperative language, like fair enough. But what it does, it produces a data structure that declares the desired state, and the declarative automation happens just like it would otherwise. Those are 2 separate concerns. So that's the language part of it. Then the second part of it, and that's why I'm working right now, Sindhu hinted I'm working on the serverless team, is what is really, and meta model is one of those big architect words, but what is the meta model? We talked so much about topology, right? What is wired to what? That was where we even started. Now, most of current cloud automation is really a resource hierarchy. You have an availability zone, you have a VC in there, an auto-scaling group, and then EC2 instances in there, right? This is like the nested, it's sort of like the Russian doll kind of thing, right? It's a hierarchy of nested resources. All the examples we gave here, we never really talked about nesting and hierarchies. We always talk about data flow, essentially, right? Where does the event originate? Where does the event go? Who routes the event? Who consumes the event? It's a completely different dimension of your architecture, right? Both are valid. They're different lenses on the architecture, but we feel that in the serverless environment, this topology, this data flow is actually more interesting than the hierarchy because you rarely have a lot of nesting. You have event-driven architectures, so what goes where becomes more interesting. And then the last dimension of this is, so we made a big pitch here, right? We said, hey, the application code and automation code, you can write this in the same language and shift stuff left to right. A valid question should be, do we still need both? Why do we have 2 separate thingies if they're the same language and you can do one and the other, right? It's a legitimate question to say like, hey, can I just do this out of one source file? And the answer is many folks actually working on this. The keyword there is infrastructure from code. Basically, you're writing your code. Some folks making custom languages to do this. Other folks do annotations, right? There's clever things like cloud compilers. Even I have written CDK programs that can run locally as application code or as CDK code for deployment. So it's the same code, and you can run it locally and execute it, or you can actually go and deploy it to the cloud, and it's the same code. So you really can, it's TypeScript, you really can tell which of the 2 it is. Very, very interesting area. One of the key considerations here is, do you want your automation to be implicit or explicit? Do you want it to be sort of automatically derived from your code, or do you rather want to explicitly say, hey, that's my functionality and here's my topology? If sort of I reveal where I stand in this camp, and let me start with the last one first, I feel there's still a lot of benefits of doing the automation explicitly. It's great to use the same language, it's fantastic to be able to refactor, but I like to say, is this one lambda? Are these 2 lambdas? Are they connected via destination? Is this via queue? Is this SNS or SQS? Because that really impacts my runtime behavior, and I'd like to be more explicit about it. As I hinted, right in the middle, I'm in the bottom camp. I'm very much a fan of event-driven applications and put that in the front, not the hierarchy, and that's something I am working on. And, well, you probably guessed by now, we're a little bit in the object-oriented camp here because that's where we build our examples. I have a talk on this topic now. Ironically, that talk is in German. So if you speak German, you're welcome to come. This is in the Global Lounge. I will try to make an English video recording of this, and that dives deeper into this whole application architecture as code topic.
So Gregor, let's go back to 300 level.
Okay, fair enough.
Because refactoring is not just about language styles and meta models. To make this work, you also need to know how you can incorporate refactoring within your existing team structures. So, yeah, let's go to the next slide.
Yeah, I'm the click person here. Okay, good.
So we see organizations use one of these two models when structuring their teams. The first one is where you have a single team that builds the application end to end. So this is the team that will all do the application development, build the infrastructure to support that application, and also do security. Now, this model has the lowest friction when it comes to refactoring, because all the changes that we talked about, changing from Lambda to DynamoDB streams, that all can be done within that same team. This might look like an easy model and ideal, but then to get all that skill sets within that one team is not easy. And that is why we see many organizations use separate teams, each owning different aspects. For example, your development team will only focus on writing the business code and providing your packages like NPM or zip file. Your infrastructure team builds the foundation infrastructure for those applications, and sometimes you also have a separate security team that focuses on maintaining your guardrails and making sure your compliance and auditing is in place.
So you also have some granularity and topology questions here, but
Yeah.
on the team side, right?
Correct, yeah. So if you have something on your left, like your split team model, how do you do refactoring? What does that interface look like? So we have some recommendations for you. Now, if you have split teams in your organization, your platform or your infrastructure team can focus on the foundational services like your networking, your monitoring, your logging, security, which forms the core on which the applications would be built. Your application team now writes the application code, but in addition, will also be responsible for automating all that application-specific needs. For example, your Lambda destination, your SNS topics, your routing, and DynamoDB streams, all that we talked about needs to be within this team. You do not want to slice it here.
Yeah, if you have to file a ticket to get your Lambda destination set up, you're probably in bad shape.
Exactly, and then nobody will be happy at the end. So all of those changes should rely within that same team, even though you have a separate operations team. So that was about how you can manage with the team structure. Let's talk about now tooling. Now in your organization, if everyone agrees to use the same infrastructure as a code tool, for example, AWS CDK, then your teams can build higher level constructs and reuse them, just as they would do with code. For example, S3 buckets with encryption or databases with retention policies, and then they can share that with your development team. Now we do acknowledge that in large organizations this might not be the case. Your platform teams might have, infrastructure teams might have already invested into, say, CloudFormation, and your developer team is more going towards object-oriented, so they prefer using AWS CDK, for example. Now, even in this case, your teams can share or build upon the CloudFormation modules, but it won't provide the same higher level abstraction as the CDK construct does. Now, what we want to say here is both these models work in a split team mode, and we do see that happening often.
Yeah, just don't split between your Lambda function and your event bridge, your destination. That will not be a good split. Otherwise, this will work in either way.
Yep, keep that change within the application. They will write the automation code as well. Now we talked about how the refactorings primarily comes to your development team. And so it's also important to know where in your development life cycle does this flow. Basically, we get asked this question a lot. When and how often should I refactor? And for that, the first piece of advice comes from Martin again. He said, if it hurts, do it more often. Martin is in a masochist, but then we ourselves know this from our own software delivery.
Oh, yeah.
Now, if you are releasing your software once in every 6 months, it's surely going to be painful. So the same applies to refactoring. Just like you do continuous delivery, you should be doing continuous refactoring. In fact, refactoring is not separate from software delivery. It is a part of your software delivery. So you shouldn't think like, oh, we are doing refactoring in this sprint, so let's stop your software delivery. Now, if your teams find that refactoring is painful, it could probably be because you are lacking functional test coverage and automation. So now refactoring is a driver to improve your software delivery hygiene. We are at reInvent, like we said. Be prepared for all the announcements that come. And we don't stop there. We keep releasing new features and capabilities throughout the year. And so should you be constantly looking to improve your solutions. Lastly, adding any code or functionality increases the complexity of your application, like the additional wiring code or Lambda functions. Now, to bring your complexity down, have the continuous refactoring mindset, because that will help you moderate your development team's velocity.
Yeah, and that's really the same with serverless refactoring as it is with application code. As you keep working, the entropy of your system just goes up as you keep adding things. That's totally normal. So refactoring is the best way to bring that back down. And that is true for application code and sort of classic refactorings like extracting methods and inserting variables or inlining expressions, as it is for the serverless refactorings. So it's already time to summarize where we are. So I hope we convinced you that with modern cloud automation, it's not about toil and just like repeating tasks and I need a server, right? In the serverless land, that's all done for you. So cloud automation takes on a very different role, and really the lines between application code and automation code blur, and that's where the whole refactoring story comes from, that you can start shifting behavior from one side to the other. As Sindhu just highlighted, right, that doesn't mean that one team needs to do everything, right? There's traditional team structures, there's infrastructure teams, often they use CloudFormation, they use Terraform. That is all fine, as long as you don't make it that one of those teams has the license to do automation and the other team does not. That will not work in a serverless environment, right? Because that event bridge pipes that we put in, or that destination that we did is, well, that needs to happen at the same time we take the application code out. So the developers must also be authorized, if you wish, to do automation. That split simply otherwise makes no sense. Nobody owns automation. You cannot take that away from anybody in the cloud. And then, last thing, Sindhu mentioned is that, it's not sort of once a year you stop and say, oh, we really ought to refactor kind of thing, but it should become second nature and just be part of your overall development cycle. Well, with that, we only have one last message. As Werner would say, now go refactor. I hope you have interesting serverless applications that can benefit from this technique, and should mention, this is an open source project, right? So you can actually contribute to the catalog.
Yeah, so as we said, all those refactorings we're making as a community project. So if you have ideas or if you have refactored, feel free to reach out to us, contribute, and make it available for everyone.
Yeah, and once again, the pointer, right? If part of your operational considerations is switching cost, right? And how easy is it if I should ever need to take this somewhere else? There's a whole other session about this on Thursday, 11 o'clock, ARC 307, that talks about modern cloud applications like we talked about today, and switching costs. So thank you so much. I hope this was a good start for the week on Monday at reInvent. Apologies for the little audio-visual interruptions, but at least we showed that we're not reading off the slides, but we can still present even if the slide shows something else. So thank you for that.